Hi, and welcome to another flipped learning lesson for Algebra 2. Tonight's lesson is on forms of a line. So, linear functions can take different forms and different equations that you learned in Algebra 1. And the most familiar one that you probably learned first was the y equals mx plus b form, otherwise known as the slope-intercept form. Now, when you were taught this form back in Algebra 1, you were probably only taught this form and told that every single time you wanted to graph a line or write the equation of a line, you should always solve for y and get it in the form y equals mx plus b. Recalling from that experience, the m is your slope, the b is your y-intercept, and your teacher probably told you has coordinates 0, b. The slope came from the change in the y over change in x, and as we learned from yesterday's lesson with average rate of change, the average rate of change on the curve mimics the slope between any 2 points using the secant line between those 2 points. And we talked about how the rates change along a curve at different points. So tonight, though, we're going to focus just on lines. Now, the y equals mx plus b form is useful for an Algebra 1 student, but in Algebra 2, we have a more preferred version of a line. The preferred version of a line is what's known as the point-slope form. As the name indicates, the point and the slope are clearly indicated in the form of this line. And it's derived from basically the slope formula. So we know that the slope is delta y over delta x, which equals the difference in the y's divided by the difference in the x's. In order to figure out the slope, you were always told that you need 2 points to figure it out. One with a notation sub 1 and maybe the other one without a notation, or sub 2 with a sub 1 notation on the other point, but they correspond. So the point xy and the second point x sub 1, y sub 1. Now, if I take this form and I take the x minus x sub 1 and multiply it on both sides of the equation, we're going to solve for the change in the y's. So, lo and behold, if I were to do that, the form y minus y sub 1 equals m times x minus x sub 1 becomes the preferred point-slope form of a line. Now, this preferred form is preferred by not only Algebra 2, but pre-calculus, and has a direct relationship to calculus, which you know you're going to end up taking calculus next year. And, oh, look who just walked on our set, Mr. K.
Hi.
So,
Hi,
Mr.
Miss
K
Donahue.
is
What are you doing here?
We're going through the point-slope form and explaining why the point-slope form is preferred. So would you like to just interject why this is the preferred form?
I like this one much better as well. Also because sometime later on in calculus, I actually take this version and I move the y1 term over to the other side by adding to both sides. And this version, to me, has a lot more meaning, because to me this means the second function value is based on the existing function value, and then you can add on some change, rate of change, over a certain interval. Oops, that should have been a B, and that should have been an A. So yeah, I like this. I like what you're doing here. And yeah, this point slope, I love it just as much as you do. And actually in calculus, I'm gonna change it a little, and I'm gonna go one step further.
So remembering the y connection to the function at the value a, remember f at a simply means the y value, and f at b means the other y value. So we're going to connect that, and you will have to stay tuned to next year's calculus class to find out exactly what that connection looks like. But as we move to this preferred form of a line, we're using it so that we can make the transition next year easily for you to see what Mr. K has in store. So thank you for popping in.
You're welcome. You're going to do some examples?
We are going to do some examples. So
Yay.
what we're first going to do is write the equation of a line given 2 points. So there's a few things that you have to be able to do in mathematics. You have to be able to write the equation of a line given 2 points. You have to be able to write the equation of a line given 1 point and a slope. And write the equation of a line giving your x and y intercepts, which I hope you're saying to yourself right now, well, that's just merely 2 points. And can you think of any other ways that we would write the equation of a line? Maybe parallel to a line given?
Oh, yes. They've done that last year, don't they?
Right.
Parallel
Parallel and perpendicular, which was a topic in geometry. So parallel and perpendicular, but we would need a point, wouldn't we? Through a particular point. Through a particular given point. Okay, so we're going to practice these skills right now so that you have all the different ways that we can write the equation of a line. Okay, so let's erase our board. Take a moment to write down any questions that you have right now. And we're going to start with our first example of writing the equation given 2 points. Okay, so my 2 points today are 1, 7, and 4, -5. Now, these 2 points, I'm going to use the point-slope formula. Again, remembering the y's. In this case, I'm going to put y sub 2 minus y sub 1 equals m, x sub 2 minus x sub 1. And I'm going to basically just throw them in the formula right now. We're going to put them in. We're going to solve for a slope value. So let's label which points.
Wait, Miss Donahue.
Yes.
Are you going to calculate the slope, or are you going to have the kids find the slope from a graph?
Oh, we could do it from the graph. So for your visual learners out there, let's take the points and do that. 1, 2, 3, 4, 5, 6, 7. Good thing we have exactly 7 boxes on this nifty graph. And 4, -1, 2, 3, 4, -5. Okay, so if I were calculating the slope, and let me get my straight edge to try to be as straight as possible here. If I'm calculating the slope from this point to this point, it's simply a calculation of my rise to my run. Now this is decreasing, and so if it's decreasing, my slope is going to have a negative value. Next, you want to count how many boxes up. So that's the change in the y. Well, if I'm going from -5 up to 7, that's a total of 5 boxes and another 7 up, making a total of 12 up. And from this x value 4 to this x value 1 is a difference of 3 over. Rise of 12 over run of 3. So I've got 12 divided by 3, or the slope is, I think I'm out of the screen, the slope is 4.
Ooh, but you just told me a minute ago that it's a decrease.
Oh, right. So good thing Mr. K's here today. Must have been a long day for me. So the slope of this function, should this be on this?
No, you're going to put a negative there.
Oh, I'm going to put a negative. -4. Okay. So the -4 is going to get substituted in for the slope. Now, since this is a point slope form, I don't need a second point substituted down into the function. I need a point, 1 point. So you pick which point you want. It doesn't really matter which one you pick. Some of you may choose to pick this one. I'm going to pick this one. And you could do it both ways just to see that you're getting the same equation. This y is just the variable y. I'm only substituting for one of the y coordinates and one of the x coordinates. This is it. If you were to put this as your answer, that's full credit. That's the equation of the line. I don't really need to do anything else. I could take the equation now and rewrite it as such, adding the 7 to the other side, putting it in the form that Mr. K was talking about in terms of its application to calculus.
And having just one value on this side.
And solving for y, which is okay as well. But this is equally correct. So either way, it's a very simplified version of the formula to just plug in.
Now, but Ms. Donahue, what if I had put in this x value here
Instead, as a mistake.
But why? That's an x.
But it's not the corresponding point that I'm using. So if I'm using one point, I have to limit it to just those coordinates. I cannot mix and match the coordinates because the point slope formula requires one point and one slope only. Okay, so the next equation we're going to practice now using our x and y intercepts. So next problem. Okay, so now in your mind right now, I want you to jot down the coordinates for an x-intercept where the root of the function, the x value is -2. And think about what those coordinates would look like. And then we're going to also use a y-intercept of a +5. So we want the equation of a line with a root at -2 and a y-intercept of +5. Okay, so let's graph it first just to get an idea of what it looks like. Pictures are worth 1,000 words. So we're going to graph the root at -2. So a root of the function is a x-intercept, and now I want to label the coordinates of this point. Okay, so every x-intercept has a value of 0 for y, so -2, 0. And y-intercepts, 1, 2, 3, 4, 5, have a 0 for x. So again, this is really just back to a point and another point and calculating the slope and then using the slope-intercept form. So let's take the slope first. Now, if I'm reading the graph again, we always read our graphs from left to right. We read it in that direction just like we read words. We are going to connect the 2 points and calculate the slope. Now, the kind of a line is this. It is increasing because as x are getting bigger, then y's are getting bigger as well. So it's an increasing on that interval. And so it's going to have a positive slope. We're looking for a positive slope. Calculate the change in the y. This goes up from 0 to 5. So 5 units up and -2 to 0. And that's 2 units over. And so we're going to have a positive slope of 5/2. Okay, our slope is 5/2. Our point that we're going to use, again, we can pick which one we want. Any preferences?
See, I would want to avoid the negative just because.
Okay.
Ooh, but, you know what's going to happen. So let's use the negative.
Because it's going to turn positive.
Yes.
Ooh, okay. So the point that we're going to pick is -2, 0. So again, y minus y sub 1 equals m times x minus x sub 1. We're going to plug in the y value of 0. Well, y value of 0 is just going to be a y on the other side of the equation. And the m is 5/2 x minus -2. And that, just as we expected, is going to turn into a x plus 2. So y equals 5/2 x plus 2. So knowing if you wanted to confirm that the y-intercept was actually 5, if we distributed this through, we'd have 5/2 x plus 2 times 5/2, which the 2's would cancel and you'd end up with 5, which is what we expected here. So it's quite easy actually, and probably a good idea to use the y-intercept since that automatically solves for y in the equation. Okay, the next is parallel and perpendicular. So two other concepts that you need are ones that you learned from geometry. So we're going to refresh our memory about lines in geometry, and we're going to talk about lines that are parallel and perpendicular. So first of all, lines that are parallel, you should remember even from Algebra 1, parallel lines, thank you, parallel lines have equal slopes. So parallel have same slopes. Okay, so if I want to write the equation of a line that's parallel to a given line, so given an equation of a line, and a point not on the line, write the equation of a line parallel. So we're looking for writing an equation of a line parallel to a given line through a given point. Okay, I'll give you a second to just jot that down. Okay, so our original equation we'll say is y equals, and let's call this 1/2 x. Do I have one written there? 1/2 x, and I'm going to say minus 3. Now, the minus 3 is really insignificant. What the important part of this equation is the slope. I need to know that my slope is 1/2 because parallel lines have the same slopes. But the other bit of information I need is I need a point of which to draw this line through. And the point is necessary because there's an infinite amount of lines parallel to any given line. So think about that for a moment. If I have a line, I'm going to call my ruler my line, I can put an infinite amount of lines anywhere on the graph that are parallel to that line, just having equal slopes. So let's talk about a specific point. Okay, so pick a point. Pick a point, any point. But not one that's on this graph.
I pick 3,5.
Okay, so let's see 3, 5, and let's see if that works. First of all, let's graph the line 1/2 x minus 3. So I'm going to set up my xy axis, and I'm at a -3 y-intercept, and I'm graphing a 1/2 slope, which means I have a rise of 1 and a run of 2. And now I'm going to connect those for the original line, and I want to draw a line parallel to that. Okay, so the parallel line then has the same slope, and we want it through the point 3, 5. So 3, 5 is here, and as long as my slope is the same, which is 1/2, then I'm guaranteed that this line is parallel. So it's helpful sometimes to draw it first, and then when we get the equation, we can confirm that it's truly the equation. We could even use our graphing calculators to kind of confirm the results as well. Okay, well, they look parallel, but just because something looks parallel, you can't say it's parallel. You have to be sure. So I know that the slope is the same, and so I am pretty sure that the rise here and the run here is equal to the rise, the run, and again, Slopes are constant on linear functions, and so anywhere I check it, it should be that slope. Okay, so slope is 1/2, point is 3/5. To write the equation now, I'm going to use again the point slope form of the line. So the point slope form, y minus 5 equals slope times x minus 3. And that's it. And that is a completely accepted version of an equation of a line. It's accepted on the Regents exam, and no one's going to ask you to solve for y, and rarely do they ever say put it in one particular form, and that's a correct answer. You may wish to solve for y by adding 5 to the other side. Maybe you want to distribute through. I would not. I would leave it. This is great. That's an equation. That's a great answer. It's a correct answer. And it's really easy because it did not require us to find the y-intercept. We didn't have to put it into that ugly form y equals mx plus b and solve for b anymore.
Especially since it's a decimal this time.
Yeah, I mean, it should be a decimal you could figure out. I mean, it is only one box up and 2 over. Hopefully, our students are smart enough to realize that that would be halfway through the box. Let's hope that they already knew that. Okay, so the last part is writing the equation of a line perpendicular. So why don't we use this same line? We'll use this given line right here in order to write the equation now of a line perpendicular. Okay, so perpendicular, when you learned from geometry, is 90 degrees. So I'm looking to come at this line at a 90-degree angle. Now, if this is a line with a positive slope, and I'm trying to write a 90-degree angle to this, I'm hoping that everyone at this point is going to understand and see that my slope is going to be negative. Okay, so I'm going to pick a point off this line to draw a line and write an equation through it. So let's pick the point negative 3, 2.
Negative 3, 2?
Negative 3, 2.
All right.
I'm going to graph that point, negative 3 up 2. And now I want to draw and write the equation of a line perpendicular to the given line through the point negative 3, 2. Okay, so let's get rid of this one. Okay, so slopes. We need to talk about perpendicular lines and slopes. Perpendicular lines have, well, that's a positive slope, and I know in order to get perpendicular, I would need to come down at a negative. So opposite. And then this line, if I can see how I have a rise over run 1/2 slope, when I do this line through this point to this line, I'm kind of seeing that it's going to be steeper. It's going to have a steeper slope than I'm going to have here.
Could we put it back there?
Sure.
Can we kind of just move it up a teeny bit? So right there, let go.
Oh, and make it
Hold
perpendicular.
Yeah, perpendicular right there. And it does look like what you're saying, it is steeper. 2, 1. 2, 1.
So if I come down through that line then, at a perpendicular angle, I should see the connection that not only are they opposite, but they are also reciprocals. So recalling what a reciprocal is, basically it's your fraction, the numerator becomes a denominator, and the denominator becomes a numerator. So I teach my Algebra 1 students, think of reflipical, reflipping the fraction. So a slope here, this line, the original line has a slope of 1/2. So the perpendicular line will have a slope of opposite, meaning if it's positive, I need a negative, and reciprocal of 1/2 is 2 over 1, or simply put, just m equals -2. Okay, I have the slope, I have a point, I have a point slope formula. Y minus y sub 1 is m times x minus x sub 1. Subbing in the y and the x, y minus 2 is negative 2 times x minus negative 3, which flips to a plus 3. And you're done. And you can leave that fully in this form for full credit. Nobody is going to ask you to change it. If you have to write the equation of a line, you leave it, and that's done. Okay, so that is all we have for today's lesson on forms of a line. I hope I've converted you to realize that the point slope form is the preferred and superior form of a line. Okay, that is all for today. Hope you enjoyed the video, and keep doing math.
Keep mathing.
Bye.
Bye-bye.